Hello, my name is Cynthia and today we're going to be learning about Pythagoras Theorem. So before I start, I'd like to mention that Pythagoras Theorem is part of the units that are essential for GCSE mathematics, and it is really necessary that you know it before any exam that you sit, just because it's part of the foundations when going forward after GCSE. So let's start off with where Pythagoras Theorem is applied. So Pythagoras Theorem is applied on any right angle triangle to find any missing lengths. So you're probably wondering how to distinguish the difference between a right angle triangle and a normal triangle. So here you can see there's a vertical line here and there's a horizontal line here, and they are perpendicular to each other, making 90 degrees. So let me give you an example of another triangle. So this is just a random one I'm drawing, and I'm going to be drawing an angle. So now you can see this is a regular triangle with an angle, and this is a right angle triangle with its 90 degrees angle. So now would you like to tell me what you see that is different between the two triangles? And yes, you're right. The normal triangle that I've drawn right now is curvy, whereas the triangle here, the 90 degrees, is represented like a square. So any triangle that's got a squared-like angle always represents 90 degrees. Whereas this triangle here, you know it is not 90 degrees because it's curvy. And this is an acute angle, so an angle less than 90 degrees. As you can see, it's less than 90 degrees. It's not, this is 90, but the one I drew was less. Yeah? So now, going forward with applying the equation, a squared plus b squared equals c squared. That is the equation that we are going to be using to find a missing length. So before we use the equation, we need to know where to apply the letters a, b, and c. So here's a right angle triangle. A can be applied on each line because there's 3 different lines to the triangle. The vertical line, the horizontal line, which is line 1, line 2, and the diagonal line, which is line 3. So we have 3 letters, A, B, and C, to coordinate with each line. So let's start off with allocating A, B, and C. So A would normally go on the vertical line, and it could also go on the horizontal line. Just because they are perpendicular to each other and they form a 90 degree, this could be B, but in this instance I'm going to put this as A, and here it could be B. Before I go into changing the annotations, I would like to mention that at all times the diagonal lines are always C. You cannot change that principle, it's always C. So you cannot swap A for C, or you cannot have B here for C. C always needs to be a diagonal line, whereas here A could be B. Not that it's wrong, but I'm just crossing it out to show you that it could be the other way around. Sorry about that. So it could be B and here it could be A. So it could be the other way around, but it depends on your preference. So that is the annotations, and that's the equation we're going to be applying. So we're going to be squaring whatever number to find out the missing length. So now you have a go. You tell me. Now I'm going to be rubbing this all out. I've drawn a separate diagram at the bottom, so maybe you can have a go at that. And tell me where you'd put A, B, and C, so you can discuss that with me. So yes, you are right. A could go here, or could go here. And yes, it could either take over B as well here, but it can only be one or the other. So it could either be AB or AB. And here is always C, yes. The diagonal is always C. And it's a right angle triangle, and we only apply the Pythagoras theorem to find a missing length. So now applying this to example 1. Find the missing length PQ. So we're going to first check whether they satisfy the 2 principles. Is this a right angle triangle? Yes, it is. Why? Because we can see a right angle triangle right here. it's not a right angle triangle, sorry, it's a right angle, and you can see that, which makes it a right angle triangle. Okay, the first principle is satisfied. The second principle is there a missing length in this right angle triangle? And yes, there is. PQ is missing, as PR is 11 centimeters and RQ is 9 centimeters. So yes, it is missing. So now we can apply the equation a squared plus b squared equals c squared. So let me copy that so we can apply this in this question. So we know now that this a squared plus b squared equals c squared is going to be applied into this question. So before we get into substituting the values, we need to find out which length, so which, is it PR or RQ or PQ, that's going to represent A, B or C. So we went through this earlier. This could be A, 11 centimeters could be A or could be B, but likewise vice versa for R and Q. So let's say PR in this case is A, RQ is B, and always PQ is C because it's diagonal. So now substituting the values in and leaving the missing values as it is, A squared in this case will be 11 squared. Now B squared would be 9 squared. And C squared is here. Do we have any length for it? No, but we have for here 11 for A, RQ 9 centimeters for B, but for PQ we do not have any. So we are going to leave that as C squared. Okay, so now only working out C squared, you're going to have to type 11 squared plus 9 squared in your calculator, because mostly it will be calculator questions. So 11 squared plus 9 squared equals 202. Now if you look at this question, you can see that PQ only represents C, not C squared. The reason for why we use C squared, so A squared plus B squared equals C squared, is because that is the only equation where you can find the particular length C. So PQ does not stand for C squared, it only stands for C. So in order to find C, you're going to have to square root both sides. So square root 202 would be 14.21. And this would be 2 decimal places. And if they ask you for 3, you write 3 accordingly. But it depends on the question. In this case, it's not specified, so there's no problem in writing it in however way you want. But necessarily, in this case, I wrote it in 2 decimal places. Looking at the second example, find the missing length RS. So the two principles we need to check again. Is this a right angle triangle? Yes, it is, because RS, the vertical line, is perpendicular to the horizontal line ST, making a right angle triangle. Perfect, that's ticked off. The second one is there a missing length? Now the question states that, but can you see that in the diagram? Yes, there is. RS has no length value whatsoever, whereas RT does, is 15 and ST is 7. So now, as they all satisfy, we are going to be applying the Pythagoras Theorem. So, writing down the equation again, and then we substitute which letter goes on which length. So, RS, what would you like to put that as? Okay, we'll put that as B this time around. What about ST? The only letter left is A. And as always, RT is C. Okay, now you are going to have to substitute the values into A squared plus B squared equals C squared. Now that we have labelled each line of the triangle, it will be easier to do so. So what's A squared? 7 squared. And what's B squared? It's unknown. This here is unknown, there is nothing. And what's C squared? 15 centimeters squared. So now, just looking at this equation, you're probably wondering, how on earth am I going to work out B squared? Well, it's pretty simple, but the only way you can do that is through rearranging. So here, you'll be subtracting 7 squared, and here you'll be subtracting 7 squared. So this is just like little annotations of mine, yeah? So this is not part, this could be part of your equation if you want. So here it would be as b squared, as you have subtracted 7 squared. 7 squared minus 7 squared is 0. So you're left with b squared. And then 15 squared minus 7 squared. 15 squared minus 7 squared would be, if you type this into your calculator, would be 176. But do you remember when we found out c squared, we had to square root it in order to find c on its own? Likewise, b squared does not represent rs, only b does. So we are going to have to square root 176. So let's have a go at that on your calculator. So if you square root 176, it is 13.37. And this is, sorry, 27. And this is two decimal places. But like I said, the question could state otherwise. So go forward, what we would do is we would complete question 1 here. It is a bit different and it is differently angled, like here as well, as these are basically simple right angle triangles and how they would be represented. So we go more about understanding complex right angle triangle diagrams, and then we would go on to, so after we've covered this, go on to understanding exam style questions, so that like this whole thing that I'm teaching is leading on to the individual actually doing well in the exam style questions. So this is just the basics, and I would also like to confirm that whatever the individual struggles with, they will, I hope that they will be able to openly and freely, confidentially speak to me, as I am more than happy to speak to them and help them with anything they need, regardless of how silly the question sounds or how basic it may sound. I'm happy to repeat again and again if it's necessary. So these are the kind of lessons I will be doing, just so you have a rough idea. And I'll probably be setting exam style questions, so we'll be going through a few exam style questions after the lesson, and then for homework they'll be trying out more exam style questions, and maybe if they could send a picture or anything of that kind, and I could mark it for them and get back to them so that for the next lesson they're ready for another topic, so we could go forward with the content. I'm happy to do that. And yeah, so thank you very much for listening to this presentation. Thank you.